Okay, let's try this again. This is like third attempt now. After clearing my throat extensively, I need to stop smoking for a while at least. Anyway, before I get into that, let's talk about some really exciting finds from today. I'm gonna really quickly go through like the less exciting finds. I was reading into Alaskan geology because essentially I'm trying to get a bearing on what's going on here based on the magnetic anomaly map. So I've been recently talking about this region of Alaska, this general region. So, but it brought me to Alaska, trying to get a bearing. Like, when did Alaska form? Like, what is going on here? Like, when exactly did we say all these things formed? Like, that would help me get a bearing straight on. Also, I was I was thinking, is it possible these are two chakras of like a shalogram? It's possible, but anyway, let's just quickly. I'm just gonna read through some things that I took notes from Wikipedia just to get a start. I realize though that there's a good probability that some of the dates that essentially I was just trying to get a list of like regions, dates, so not anything like too technical, and also anything else that seemed of interest. So that's what I did, and the really like the first thing of interest for the Alaskan region that I found was during the Middle Triassic. So in this region of time, although as I read further, it's actually a larger range of time that these three large terrains have things going on. So it's not just in this time when this is happening, but this. So anyway, there's a lot to it, of course, and I've only really just begun looking at this. But I just thought I'd go through it so that we can be in the same place, I guess, at least as I go, and share the things about Alaska real quick. And depending on how long this takes, maybe I'll just start another video about the topic that I'm really excited to share because I just was like, whoa, nice. So real quick, there's these formations. So let's just find them. Rangalia, Alexander, terrain, Stickin. Just kind of get an image of the region. So there's Rangalia. Rangalia is, I guess, to here, and the AX is Alexander, so it stretches up further. It's interesting that this is, when I looked for the geology of Alaska, that it directs me to this region. Like, what about like the landmass of Alaska? It really looks like a shalogram. It's a chakra for sure. Good to know. Good to know. Okay, but back to this. This is the Rangalia terrain and the Alexander terrain, and then also where's the ST maybe? Yeah, Stickinia, or however it's pronounced, is over here, I guess. Here. So it's really the region where that current flowed. So essentially, there's a current flowing this way that, and also up this way, that are interacting, creating a boundary, and also just creating this region. So it seems like this current, this is my thoughts, is the current coming up the coastline. It doesn't just like deflect here, it continues to come up the coastline and physically interweaves with this other current in a way where the interweaving of the currents causes nodes between them with a greater frequency. I don't know what that was. Okay. And this probably represents this current, or this current's width right here, which is probably why this region doesn't have that going on. Like about there. Okay. Some geologists contend that this region extends southward to Oregon, which is not generally accepted. So I just wrote that. Southward to Oregon. So I can kind of see how this current, which cuts across this way, we've established. Well, it goes through here. Maybe this region they would be talking. If they're talking about a region this is connected to, it would almost have to be right here through here. If that's Oregon yet, I'm not sure. Let's look. It's pretty close to Vancouver. So this region here probably has an aspect, enough of an aspect of the Rangelia for the Rangelia terrain, this current, to be detectable down here. So there, to the geologists who contend that it extends southward to Oregon, it does, but it's certainly, to the geologists who counter that, it is not the same. Like at this corner, the current that comes out underneath of Florida and Mexico collides with Australia, which was here, and flows up this way, as well as goes under it and other things, but focused on this region, it goes up this way, flows along here, and then right at Vancouver, it begins to flow underneath a second current going the other way. And this current, mind you, is going along the equator I talked about yesterday. How there's this band right here that wraps around like this way, but went before the Earth expanded, wherever exactly it went over here. But the band, I believe what happens is it wraps from the puncture hole. I'm just going to assume people are at least somewhat aware of what I'm talking about, so I don't have to elaborate further. Okay, the puncture hole, it wraps this way, and generally along here to then flow in here. So like, I believe this is the equator that is following along, but then it like continues to follow along the equator. So that I've suggested that in the last few videos. So because of the things that I read about in the geology of Alaska, there's going to be some times when the equator seems to come into play. Okay. Two conflicting hypotheses on its formation, and we're talking specifically about this region right here, which is so weird, again, that like the geology of Alaska is really focused on this region. Knowing that this is a shallogram, though, it really, now that I see it, it almost has like a snake's head and a second snake head. where there's one current going down that way and then another cutting across over there. Because there is one current that goes straight through here that doesn't bow out here, but there's a second current that bows out. And maybe this is another snakehead that comes in this way and across here and bows out this region. And then is thin and cuts across here, straight across down through here, and creates this wall. Okay, so two conflicting hypotheses. So I find this of interest because it shows that there's anomalies around it that maybe can point to things. Okay, so accreted at a northerly latitude near its current location. So either it was accreted here, or it originated. So there's a mountain chain here, right? This is crazy. There's a mountain chain here, and yet the hypothesis for where it originated is Baja California. Is the second hypothesis of. So I can see why they're conflicting hypotheses. Like, people are like, what are you talking about? They formed down there. They formed, obviously, like, generally in their location. Maybe they moved a bit in some degree, but they didn't form down here. What are you talking about? Okay, let's go through the hypotheses now. So the northern hypothesis, the one that they formed up here, says something about the Caledonide closure, which I noticed when I looked up what Caledonide is. Is it pointed to a region over here? So there's a relationship to this region over here somewhere around the northern Australia region. Maybe into the islands. I'm not sure if it was like here. I believe it's on like the boundary of this, generally on the northeast. Let's just look it up. That's just Caledonide. Laurentia. Okay, there is Hudson Bay. Greenland. But I believe what I've ended up finding, maybe it's this orogeny, is actually in. No. What? Well, it says the closure associated with the closure of Iapetus and Rheic oceans, which are along basically the west coast of North America, but before additional accretions occurred, before these currents added new underlying continental shelf to support overlying surface that's not at too low of an elevation. But specifically, it says closure of Iapetus. So let's just look this up. Let's go. I don't know what I'm doing. I'm like reading from my notes. Closure. Maybe I need to go to this one. Here we go. The northern hypothesis. Closure, or geological evidences indicate that the Caledonide closure, I wish this had some reference to that. Maybe I can click this link. Here we go. This should tell us what they're referring to. Siberia. This is so good. I don't know what we're looking at quite yet, but I see its potential already. Oh, this is where this image was from. Okay, okay. This is good. Nice. Nice. Okay, I'm really trying to find... Where is this? British Columbia. That's not what I'm looking for. So my thoughts, I guess if I just kind of... Here we go. Not sure. I guess they're up here, maybe. Not sure why they would be interacting. According to theories. Like where? Okay, there's so much about this. This is more where we should be. There's so many things that are like because of plate tectonics alone. If we had an Earth expanding model, like none of these things would really be quite as they are. Is that like Tamir Basin kind of relationship by chance? That would be insane. Because of the thing that I'm really excited to talk about. Okay, regardless, let's go back to this. Sorry for this being a little slow. Okay, closure. So my interpretation of this is Iapetus being I guess on the where these maps are so hard to read sometimes. It's got to be along the west coast. It's just got to be the basically what is forming in the Pacific. If we can pull up where might it be? I feel like these have water in them. Northern southern. There's that. Here. So, like, there's a current coming out underneath Mexico that then flows. It in one direction. Basically, it hits Australia. It hits here. It hits, like, right there. And just pushes into it and then goes out to the sides. And in one direction, it goes along this region. And in the other direction, though, it flows more freely, so it balloons into the North Hemisphere, creating this huge, it balloons this way around, cutting around here, which is when it flows along the eastern boundary or western boundary. I'm like, I'm doing it. soon, soon as that happens, it flows along the western boundary here of North America that is being formed because there's a current, I believe, cutting this way, going this way, that then when it reaches here, maybe I can get these both together. I don't know what this is from anymore, so part of me. Maybe I can find what this is from. I must have like I would wanted like I would have wanted the reference. So I'm a little confused why I don't even have it in the. I must have it somewhere. Anyway, let's just move on. Okay. So it goes around there and move on back to this, not to move on, but to me not finding the reference part of me. Maybe I can find it later and put it in the video. I don't know. But it goes that way and it begins to just flow and sever this region while this current flows on. So essentially there's opposing currents, I guess, one above, one below, that's flowing that way, and one flowing this way, and this one continues to flow to the tip of South America, where it basically passes this other current. So, like, in order to begin to flow into this region down here, it has to first pass the current somewhere, so it does so right there, where this current that's coming this way from here's Northern Europe, India here. So basically it flowed this way here and then around Africa. Around Africa, maybe there. Yeah. And then into this region where I believe it first off it went between Greenland and Canada this way initially. But there's another current also coming from India directly. Wait. It's essentially originating right here and then flowing this way. Although maybe it just flowed this way. It might have just flowed this way. Because that makes way more sense that it just flowed this way. I was just trying to account for the East African Rift by saying that it initially flowed this way and then like later on it flowed this way, but maybe initially it flowed this way and it just didn't have to go into the East African Rift. But then once the Earth expanded, the current that was flowing that way then went into the East African Rift. Why? Like, where is North Africa here? I'm not sure if this is completely accurate. Anyway, okay. Let's think about this North Pole region. Here's Siberia. So there's a current that goes basically this way on the east coast of North America, past this Appalachian belts, down through underneath Florida and underneath Mexico, where it then reaches South America and then goes out through South America into the corner of Africa, where it then just flows around the nucleus there. I believe also Africa's nucleus was like every body seems to have some sort of like nucleus system to support its structure, and its Africa's nucleus is in this region. But I believe it used to be over here, and it got physically rearranged by the currents to just because of the like structure of the earth being as it is now. It just is more stable there, and I think it happened by the currents flowing in through that region. Although looking at this image, it may have just flowed out this way and just kind of remerged with the current going this way. So kind of went across and remerged with this current, which is then again coming across this way down through the Appalachians, although, and then this way. So maybe it's possible that it went all the way around, and then once it went around, it came through this way. Like, and then went up to the Siberia, where it wrapped around and essentially caused novas. So maybe we can look at shalograms a little. The energy just propagated inward, reached this like the top of the earth, and began to cause novas to spread out the region. Like this. So this is that like this bit here, and then around here this is maybe like the Siberian traps even. So the energy just physically flows around this region and causes all these novas. So maybe it occurred in that way, where it flowed around and then essentially wrapped around here, and then drained into the earth. It probably had formed some sort of energetic bond by tapping, like maybe dendritically overlaying a terminal of the earth or something. Okay, let's keep going now. Let's keep going a little bit. So the Iapetus Ocean would really be this current. So this current's flowing this way and probably putting some energy between the chakras, like starting to channel through there, so as to open this like space. Because these are definitely chakras, just to point out chakras. Everything's shallogram based that I'm talking about pretty much in a lot of ways. But they're all over the place. Chakras like this, but just more complexly, where as they get larger, this like side mound here looks more like, whoa, like a side mound, like that thing, to a point where it physically looks like a chakra, like a point with these like protrusions. So my thoughts are maybe there's some sort of let's look at this. Maybe that'll help. Now that I had that thought. Here's the strait. So the energy would seemingly be going like here and then in this way. Let's look at this map. There. So in general, what I'm getting at, let's just move on from this before I get stuck too much on this, is that this is generally the Iapetus Ocean, and then in general the opening of this region, which occurs through the North Atlantic, where this current goes up this way and gets to this region, and when it gets to this region, it flows around, causes this, but also by flowing around it, it gets sent through over here and causes the Siberian traps and these novas. But like these novas maybe are more tied to cross streams from the Iapetus, like this way, that are just generally cutting under this way. It's possible all of this just formed as like stabilization, so like none of this really existed practically. We can just assume it was a blank sheet, generally speaking, but just with a single landmass on top that was generally uniform. And then it like grew to a new radius, and this is how the currents interacted with one another as the current like swept around the earth, under the earth, and like around it to a point where it opened up space. Okay, so my thought is the Rheic Ocean. So it says, let's go back to here. Geological evidences indicate that the Caledonide closure of the Iapetus and Rheic Oceans along the Laurentian west coast, modern coordinates, also opened. So that's why I was like, I found something that related the Caledonide to over here. That's why I found it like most plausible to be related to what they're talking about. Caledonide closure. That's the problem, is it's like a region, so it's not like, okay. Okay, so back to here. Also opened an ocean between the northern margin of Laurentia and Baltica on one side and Siberia on the other. Let's go back here. Is it here? Is it possible this current going under this way? Because I generally feel like it just wrapped around. Like this. And didn't go up under there. Certainly it didn't go under Siberia. Or maybe it did initially. Maybe it did initially. Is it possible, maybe if we think about it like as if nothing's happening yet, there's just a tiny trickle of a current, and so like nothing's grown, and like there's initially a current then that just continues to go straight and straight and straight, but over time it accumulates and accumulates to more and more like this current, so that like, and then over here like it's just shaped. Like, is it possible a single current like that mapped out just continuously would produce what we see, essentially? Where there is a puncture hole in the mantle here, it then has the current go directly westward along the equator, maybe the energy, maybe like Dwarka wasn't at the equator, but the energy that tended to puncture the equator, because it seems like it traveled along the equator generally here. Just a guess though at that point, but like, and it's wrapping around this way, like that it also was traveling along the equator right here, which is, but just fanning out. And so instead of going up that way, let's just say it just continues across, in which case it then goes into North America here under this whole width though. Basically if we really look across this, maybe like to here, and then kind of again, I think this is this current. So there's one current coming in from like directly above Africa, and then there's a second, like it, da da da. I don't want to take too long. This. Just like where a lot of landmass is created. How old is Spain in this peninsula as a? I probably. Paleozoic. Oh, this formed in the process. It didn't just get uplifted, it got formed in the process. Essentially what I'm thinking is this current it was closed, like it was like this, but then over time it just kind of separated a little bit, and in between it began to build a mound of material, so that one current one portion of this initial current began to go more this way, and the other began to go more this way. But in the meantime, it just squeezed material between it to sort of begin to produce the landmass in this region. Whatever is new here. Like, winded. Like, does it have no craton? Like, crazy. Oldest rocks in Italy. Okay, now we're running into that Caledonian again. That's a good sign. Only dendrital zircons in the Alps date to the Precambrian. Anything Precambrian was before the Earth expanded. Anything Cambrian and on was during the Earth expansion process. So there was a current flowing that did not yet form probably any of this. This region is probably all formed while this current flowed from the mantle puncture hole and just created a widening lava tube on the surface that then began to form a overlaying crust as it moved, as well as form mounds in this region. But then the current as one current, I guess, initially, before this even existed. So that's interesting. Before, like, Spain existed, then this current was significantly narrower, and we can almost approximate because of how narrow this side is, even though it's probably a high velocity. It's just not sufficient width to matter in terms of like um, in terms of where the initial current was flowing out. Like the initial current was probably flowing out just here. And even this might represent like when the Earth expanded. It like created a new equator almost by like opening up. Because this was an equator. I'm pretty sure I'm going to call this From Equator to Equator now. And I'm running into things about what I wanted to say that maybe I should just bring it up soon, but we'll just keep going for now. Because I don't want to change the subject too much and it would take a bit to talk about it. I just noticed there's like a circle here. Okay, let's just keep following though. There's a path cutting across here. That generally is probably centrally located. The center of the current is about the center of this circle here. This big ol' whatever happened there. Nova, they're just open space maybe. It looks like there's a string of them. Like it's coming in, creating vortices and just like pushing the material out like a lava bubble, and then coming in and creating vortices and creating like a lava bubble that pushes the region out again. And again and again and again and again. and just creates this space for the current to flow underneath the ground. Uplifting the, like, creating mounds on the side, like by creating these novas, it's almost like if you, like, if you're trying to what am I, what's a good example, trying to move, but you got like something heavy laying on you, and the only way to move is to like throw it up real quick, and then you can move, but then you the only way to move and not have it on you is to like put some, maybe put your arms up, like create some kind of pillars around, and then it doesn't quite like have the same capacity to reach, and then the current can flow easier. So the current's just getting stuck, and it doesn't really like that. Like, it gets stuck essentially. It's like, I'm stuck. There's so much current behind me, so what it does is just novas and opens a space and a space and a space, but in a straight line in this location that then cuts across right here. This nova is probably highly related to Flemish Cap. Let's see. Let's follow this line. This looks shallogram like, this feature right here. There's so many shallogram like things that certainly are, because they are formed by similar processes, essentially the same, just in different circumstances. So I'm just trying to get a bearing on where this current is exactly flowing, so we can just trace it and trace it and trace it and trace it and see where it takes us. Essentially across there. Let's go back to this map. This is probably a good time to return to this map. It's just not quite looking directly at the region I would like it to be looking at. It's like right here. It's right at the worst location. Right along the edge where there's a lot of information even, so it's hard to tell what's happening. Crazy to think about that. Right at the edge with a lot, hard to tell what's happening. A lot of stuff going on though. But if we could just kind of move the angle of viewing, then it would be better. Anyway, I'm just thinking it goes out there. Then presumably goes out here, North Europe, like underneath, right there. And then let's just keep following it, let's say. So that looked like, maybe this, we can kind of see another circle here. Generally. There. Like where there's probably crossing currents of substantial volumes and flow rates. So like this flow rate is pretty substantial, so it's gonna have, if it collides with another current that's substantial, it's gonna have substantial novas. So there's a good chance this current cutting across is related to specifically right here. And then it maybe went in this way initially, flowing across here. Across here. It does take its path under what seems to have been like a core of at least like Canada and North America, maybe, with combined with this region up here. At least a portion. So maybe if we just keep following it, maybe the current, where was that? Like, assuming this is closed up, so maybe it's a little. Maybe here. I'm just looking, I guess. Maybe. Generally, just generally. Maybe that leads to here. Like initially a current, or it's hard to say. Let's go back to this. I got so distracted. Like, is it possible a single current that just goes on and on and on under like a single Earth could? And then I start trying to do it on like the final product Earth. It's like I don't even know what straight like a line is. It's so there's change on the scales. It's hard to. Oh, now I got a little distracted. Let's go back to the geology of this region, maybe. No, maybe. I don't watch many of these at this point. I'm just kind of tired. I just record them because I feel that it's useful and good and what I should be doing because that's what I've been doing, I guess. I'm just wondering if it could be a single current that just continuously wraps around and then just collides with itself. But with that said, it it almost has to be two currents because it goes that way and it definitely goes this way, and not only that, it goes this way with a tendency to put a mound to the north side of it, and it goes the opposite direction with a tendency to put a mound to the opposite side, creating like an upper and lower equator segment at that period in time, traveling along the equator at least. What was the equator before the Earth expanded? I know, it's a little confusing, but the Earth opened up here, which is why it's like kind of suddenly, abruptly goes from this angle to this angle because of this widening of the Earth here, so it kind of confuses that. But at the time of its flowing, when these were forming, it was much more at the equator. So there's definitely a current coming out this way that generally cuts across here and probably over here. It's hard to say though exactly. It would be really nice to have like a team effort. This could be so better mapped by people with resources and knowledge of like the things necessary to do it. Smiley face. Maybe 55 minutes in. Maybe it would be an apt time to talk about this. Tarim Basin. So recently I've been talking about, in my last couple of videos, how this is kind of shallogram-like. Notice also, now that I notice this, small opening, large opening. Small opening, large opening, even larger opening, even larger opening. So I've been talking about how on the surface we can see these shallogram features here, right here. That's fine, a good one. The dendrite feature that tends to occur like this. But not quite like that one. That's fine one. That's actually more like the shape of that. Kind of like this one, this kind tends to be. I know I got a better one. Like this, I guess. There we go. So yesterday or so I noticed this, and even if like this one even like kind of has the deformities of this, where this is more pristine looking, this is kind of janky looking. Like it's not quite the crystalline shape to make it as shallogram-esque as some other places. Like this looks very shallogram-esque. I know people don't agree, but it is. But it also, over here, we see a similar feature. And down there. And if we go to Hawaii, I probably can find this shallogram. Pretty sure it's on that island. There it is. Generally speaking, I mean, this one doesn't, I don't see any of the doubles. They don't always have this, like, double aspect to it, depending on how pronounced it is. So, like, I don't know. I wonder if it does have that. That would be crazy. That makes me think about currents flowing downhill that then run into resistance to the point where they have to go uphill, and then they physically go up, wrap around, but then when they're doing it, they're like in this little tiny channel, so they just flow up and around and then down back through, and then just maybe back and forth though. But actually, maybe more like this. Pardon me, guys. I know I've said figure eight so many times when maybe it is more like this. Or both. It's probably both. Maybe the figure eight is when they are colliding a lot and causing division of the cell in a way where the particle that can exist at the center of a shallogram, there's not one there, but there can be. So like that one's gone, but there's this material there now. So like a current is flowing like that though, where it flows downhill, but also has a momentum to it enough where it just then, like, due to the resistance of the rock it's in, the material that this is happening within, while it's hot, so it's like this is able to happen, but it's not able to exit the rock, so it flows within it, within this boundary. Just within a boundary that's like, so it's more solid than the interior, so the current can flow within the interior, but not really outside, although it can like exit and vent and so on, and below, like explode the side off. A lot of them have exploded sides off. Okay, let's find, there's another good one of that kind of thing, and then the particle there is like barely there. Here's one with the particle separating into two particles. Novas. Okay. Hopefully people listening can see that there's some merit to that, like that is kind of like this, which is also kind of like this, like they're all the shallograms. These are kind of like shallograms. Like this is kind of like a shallogram opening. This is kind of like one. This feature is kind of like one. This feature is kind of like one. Okay, so I noticed, and I mentioned this in the previous video-ish, that this region also was reminiscent of one, like right here, through up here, but then like it's missing this segment. But then this here, like especially this chunk here, is like a bigger version of this, but not as defined, where it didn't cause the reduction in elevation over here in the same way. Perhaps because of a current. This region, this here is Italy. Okay, let's go back to Alaska. Wait, no. What am I doing? Pardon me. What the fuck? This dude is impossible to listen to. He's so fun. Okay, so now that I've kind of talked about this shallogram region here, this here, I want to really, this is exciting. This is so exciting. I wonder if that right there is related to, where was that? That was here, probably. Yeah, there's definitely a nova here that extended its boundaries out to here, but it ran into resistance over here from this current. So this current runs down here, cuts across here, and starts to cross the stream, and I guess cause novas and push a boundary, which then causes the current to deflect this way and wrap into this region and just build a wall. When a current's coming in from that side. Oh, this side. Okay, let's go back. This side doesn't come in this way. We just realized that. It actually came in from over here. Around here. There. So really it goes all the way around and then in there. And that current cuts across and collides down here. possibly in other ways, depending on if it's before certain the expansion or after. One goes off this way, creates this, fills this region with this vortex, kind of like Alec Hills on a different scale. And then goes that way. I'm just not sure how it gets here. That's kind of what I'm trying to figure out. Like, does it just cut that way? Like, it just goes right up to the, right up here and this way. Date-wise, it seems to be plausible. Maybe it does in the same way as, actually, in the same way as where as I was mentioning, when the current comes out underneath Mexico, and here it begins to like create. Essentially, it's like a spray, come a very high energy beam that then when it hits something with resistance, like the previous core of like Australia or whatever exactly was under there that was resistant. It must have been something very resistant to the energy. And so it essentially, or maybe just that's where currents were colliding actually. Actually, that's what it was. It's not just that something was resistant, it's that there's also current going this way, I believe, because the storm, I believe, sent current this way. That then Australia was there, like over here on this side of Australia. So it's flowing in this way, and a current cutting across that way. So it just created this region, or flowing in somewhere exactly over here. I haven't really reasoned out that segment, but generally flowing into Australia. So maybe just the fact that it was meeting resistance from another current made it that's where it, like, basically by meeting resistance from another current began to spread out in like a disc, probably like a saw, even like a zzz, from the resistance of the beam hitting the resistance and just spreading out like a saw, and physically cut through and then allowed the current to start to flow in the preferential direction. So it did both directions like a saw would do. And maybe even initially in a straight line that like bended as the earth grew. I don't know if that makes sense. I think it would be do the opposite though. But then caused essentially hit resistance here ish, like right there, and then started to branch out this way. So at this stage, really nothing else has opened up on the earth except for a little bit, like where the current is flowing. So like where the current is flowing, we see a current flowing. It's almost like a river is flowing between the land masses, a river of magma that starts to create the Mediterranean Sea. And then when it reaches Atlantis, which was founded on a island Like Flemish Cap is continental shelf that pre-existed as an island, meaning it's like has a dense core. So if we go to like Gurnar, oops, Gurnar, this like current flowing here would generally flow into this like weighed down region, like general relativity gravity kind of way. And so if there is a lava current flowing under or between the land masses of pre-existing land of Africa, generally speaking, and of whatever exactly pre-existed in Europe and up into Asia, and that current then went under Atlantis and sank it, I guess, with an undercurrent that just kept flowing. So there was a lot of magma flowing underneath. It's probably just so low that it's, although it was flowing like on the surface over here, I'm not sure. Maybe this is underneath, like right here. And then this is the stretch that was like actually severed the pre-existing land masses, was like right there. But then it's because it severed it, it began like what was underneath the pre-existing landmass up here began to be pushed out this way to just cause more pressure into this region specifically, like because there was pre-existing landmass here. Maybe, I don't know if that's a true statement that there was. This smiley face seems to agree. I'm taking it as a smiley face, okay? Okay. Maybe it's a little derpy. It's got an eye over here, a nose over here-ish, something. No eyebrow. Who knows? Sideways, but it's okay. It's okay, buddy. This is certainly like a Nova region here. I've been saying that the current came down this way. But now I'm wondering if it came under here, like generally speaking, above the Appalachians, like across here, and then it ran into resistance here, which caused it to shoot out in all directions, including back this way, creating like a boundary here-ish. Like there-ish. Basically Appalachians, creating the Appalachians. And then this region, this whole region maybe, this kind of looks like a hexagon right here with a circle at the center. Maybe this whole region was just this big old like under layer of just magma that generally filled this region initially, and like currents fill it up later in ways that produce its final shape, but like it generally had a shape out to here of like a nova center, because of the colliding currents. Maybe they collided here initially, at least, maybe, and like moved over like this way and this way and this way. It started to, as the Earth expanded, like the collision point moved out, maybe down through Mexico, underneath, until it finally started to actually have enough upward energy to fracture, creating cave systems along the way, because there's a lot of caves in Mexico. And because let's think about this. Does that make sense? I'm not sure. I'm not sure which way it flowed here. I kind of just assumed it flowed this way because I hadn't considered that it flowed from over atop the Appalachians and then ran into resistance from the Dwarka currents. This one coming underneath this? I'm not sure. Maybe going directly south, like perhaps it went this way, upward, because it kind of looks like that based on this. Just here, it's hard to say otherwise, but and here it kind of looks like it maybe went up and down to a degree, but maybe not quite as much energetically as along the equator, but just to the poles. To the poles, maybe actually to the poles, like this current went to this pole, maybe initially, like to here, maybe. And this current went to the other pole. Let's see, was Australia previously? Present topography is the result of a long landscape history which fundamentally started in the Permian period when Australia was very near the South Pole. After the ice melted, from the current of energy flowing underneath it, boiling. After the ice melted, parts of the continent subsided, again from the current, and formed sedimentary basins, again due to the currents, such as the Eromanga Basin in South Australia. Log in, whatever. By the early in the Cretaceous period, Australia was already so flat and low that a major rise in sea level divided it into three land masses as a shallow sea spread over the land. Kind of like the North Pole thing, where this feature is. Like, where is this feature? It's kind of like here. not really visible on the Earth. It's kind of like here, though. That's interesting. This right here. Remember this shape for a second? Up, across, triangle thing, across. Up, across, triangle thing, across, and then down. So that one didn't actually show the down, but it probably has, like, it energetically has it as well. So this here, as I've mentioned several times before, is where shalligrams originate from, are found. All of these are found in one river in that region. All of them. Nowhere else. There's similar rocks like ammonites and so on, but they're not formed as, like, whoa, as these are. Like, I've never seen an ammonite look like this. I've never seen an ammonite look like that. Nope. No, sir. Nope. Nope. Never. Not ever. Never. Nope. Never. And even I've never seen another shallogram look like some of them. It's like this happens at times. So I've seen it before, but it is kind of rare, seemingly, in the ones I've observed. Nice particle in there. Okay. But so shallograms originate here at Damodar Kund, which is right here, which has itself a shallogram and another shallogram. Kind of like that. Which also has... Oops. Where is it related? No, here. Which also has... Okay, there's the shallogram that really is reminiscent of it. Where is it? This one? This one. This in the rock face happens on different scales. We can even see like the channel, like the beam. There's a beam, and then it's splitting. It's like causing. Is it a beam? Am I just assuming it's a beam? I think the current's going through here and through that way, generally speaking, and through this way and this way. So there's there's probably a heat rising and then a cross current here for some other reason, from just the propagation of the current across the surface of the earth. Some kind of thing of that nature. Okay, and that's also in this region, that picture right there, that looked like that. So there's a bunch of this kind of thing going on. Okay, we've kind of established how shallograms happen a lot all over the place. Maybe real quick I can go to my ammonite. My ammonite. My hair is out of control. Animations. Let's see, this one or even that one. So there's even a shallogram here. Okay, so I mapped this. Where did I think before that these looked like? Okay, South America, all of South America. I had not remembered that aspect. All of South America.
And then like the upper half of Africa. This is like a final shallogram. Interesting. Because there's an initial one. Maybe there's an initial one that also goes the other way. Like, I only went one way here. I didn't even get to the North America segments at all. So it's possible there's like overlying shallogram features of that nature. Okay, let me just bring up now what I'm excited to talk about. It's maybe not that exciting, but it's exciting in some ways. Okay, let's look at these caves. So there's a cave in Georgia here. Okay. That's before I go clicking each one. Essentially, there's a bunch of caves. They're in Georgia, Australia, France, Spain, Austria, Mexico, Georgia, Slovenia, Croatia, Uzbekistan, Turkey, Italy, Switzerland, okay, Iran, Papua New Guinea. These are the deepest caves on Earth. And what do you know? Where are they? They are. Here's Tarim Basin. Let's go back to this. They are. Here's this like positive negative shallogram feature, which then has this protrusion of a additional shallogram feature with this here. Let me just maybe pull up shallograms as we go through this. This bottom one, maybe like this one, is probably pretty good at representing like how it does this, and then has the inner chamber. This one doesn't, of course, have this quite the same features, but just that there it has. And then again, another low, but this one maybe is more from here out this way. And out to like here. So mind you, these are shallograms like this. Or, so like, let's find a good one before I start. Da-da-da. Good one for exactly what I want to like kind of talk about. I guess the one I just had was fine. Okay. Good enough. Where on this rock are the deepest caves? Like they're all in the shallogram region, like right in there. So like, let's go to this map. It zooms out and in so much. Okay. Here's that shallogram feature. Here's this. This is real interesting. There's a bunch of them, deep caves right at the tip of this shallogram feature. And then they're just all in this line here, generally outward from here, from the Tarim Basin region, just generally outward. And then over in Mexico, where cross currents happened here. Like if we go over here, I think it was like right around there. Right there. So looking at this map, that's generally around here somewhere, maybe here. So essentially, this is where the caves are, is where there's a current. For sure there's a current. We've established this clearly. There is a current 100% that flowed along this way and then into South America here from here. And there's another current, generally speaking, cutting across from Europe this way to make this region just like a place where currents are crossing and there's just novas happening. Like we can see them even still going on near the end probably. Like this could have been just continuously happening and happening and happening and happening and really like feeding into the like the ammonite feature under Australia. So it maybe makes some sense there, as well as like maybe energetically it's still like in line with the propagation of this shallogram feature that just continues maybe here, like there. Maybe it did like bound to have a boundary here where it just flowed between whatever the boundary was over here exactly, like here, along here. But this was over here then. So he's probably along this line, I think it is. Yeah. So this boundary and this boundary. So there's a current right here. This width. Initially. So it's initially flowing right there. Not over here yet. It has to like open this space with like novas down it, it looks like, to really allow for the current, probably once the earth expanded, to flow that way. But initially it was flowing right there between Africa and here. Which almost means that like southern Florida maybe didn't exist. I don't know. Like right past this stretch. Cause like, no, maybe not. I don't know. Maybe it was just here. Was Africa up to there. So this was there. It's just the current went that way. But just generally like more straight across here. And here to like right there, pretty much. Right there, I guess. Initially, at least. This width. With a cross current of like this width. Going through here. Pretty much the width of this. Which is why it's kind of like that. Because it was really reinforced by this current being that width, I suspect. And just creating novas here, which is also here probably. This location. In some way. I don't know. Not sure about that, but maybe. That it was that location. Okay. So that means these are like because there's a shallogram, and notice it even goes to Papua New Guinea, which was like right over here, somewhere in the shallogram like line. I didn't. Oh, let's go back to the Wikipedia. List of deepest caves includes list of caves. It would probably be good to look where, like, totally where caves are. But the deepest caves are in the shallogram locations. And then the list of longest caves, interestingly, is not. It is, but it's not completely. It has locations that aren't quite the same. So there's over there South Dakota, New Mexico, Kentucky, the Yucatan Peninsula, Brazil. So this one gives us maybe an idea because there's a current that flows in here across, widening and out across Brazil, South America, and then it flows to the tip generally. To here, so that there is just this flow that, like, especially in this region, kind of like focuses and therefore probably upwells and creates more porosity and more capacity for there to be longer, like, vent regions that are long cave networks. So that place kind of maybe gives an idea because it also from there goes across that same current, goes across, and at some point essentially cuts through the nucleus and causes the East African rift to vibrate, but then it runs into Mozambique and separates it. Or Mozambique. Madagascar. And separates it. And then apparently maybe contributes to producing this cave network. Here, where these are very shallogram related, although I would just say they're pretty much shallogram related, and that's probably good enough. These ones, interesting, they're kind of in a line. I don't know if they would have formed that way. I was wondering if this one here, when I read about it, was actually over by the shallogram features. I was thinking it was here, but it's not. So these ones that have anomalies or things that I can't just immediately explain, whereas the list of the deepest caves, they're all along the shallogram of the earth, and they reinforce in so being that way that the Earth's shallogram feature here that is there and then there, and then here is here. It is here. It's not. I'm not just making it up. Like the Caspian Sea is part of a shallogram, but so is the Black Sea. Pardon me. I was just making sure. And so is this like segment of the Mediterranean here, like specifically like up to probably up to Italy is the feature. Like the whole of it is shallogram, but like the feature is maybe like to there, and maybe even the fact that it doesn't have that additional region is because of the energy that was propagating that way. Couldn't reach it, so instead it just participated in like this to a degree. I don't know if that makes sense. I know there's like Africa had a pressure this way, it's said. But maybe that's just how it does that, like how this occurred, like some expansion and contraction repetition while the earth overall expanded. Like it had a expansion like here, but then it kind of gasket valve release like over here, and then gasket valve release over here, but it didn't do it because it got caught up there and just created this. Whereas over here it did it more completely. I don't know if that made sense. It kind of makes sense though, in terms of that there's like repetitive novas in general. And there are gasket type features, like this is for sure a natural gasket to release pressure. And so maybe there's more ways that it does it, like that. So then back to Alaska. Okay, that's good enough for the caves. Let me just quickly. This is almost 2 hours. I've made it like a half a page. I have 2 pages. It's really not that much, but for me to realistically make it through 2 pages of notes in under like 20 minutes, I'm yeah, right. I guess I could just read it, but at that point, what's the point? Let me just see what is of interest, and then I'll just start another video that will be more about the rest of these things. So the southern hypothesis of the Rangelia terrain formation here, back to this region. So back to here is what we're talking about. Pardon me as I just start talking about it. The southern region of this, the southern hypothesis of this. Dude, I don't remember what you were talking about. You're talking about so much shit that I don't know about. Like, pardon me to assume that. In that moment, at least, not always, of course. But they said that the hypothesis that maybe it formed down near Baja California, of all places, down here, instead of like at that outlet. Remember where this current's flowing across here. So we just pretty well feel like it probably did go like generally here and generally here. This side. Like maybe this was the cratons, like the previous nucleus here, which is why it's just so much mass right there, and it just flowed along it and like cut into it a bit here, but just kept going because it was enough current to keep going. Although some of it then probably swirled around here, around this way. So maybe there was a swirling current to a degree around the previous nucleus here that I'm just thinking now was there. That's went up that way. That contributed also in the novas here, maybe completely. Although I think the current did go this way and in here to just kind of fill the region and probably, I don't know exactly, but it essentially coming across here and then producing a current this way. So the southern hypothesis, and mind you, this way, this way, this way, up to here. So it's possible that it started to like produce larger, like conglomerates of material down here while still in like a liquid magma generally that's able to move it so that there would be some evidence. So that's what I'm getting at is this southern hypothesis says where is Baja originated 3,000 kilometers, approximately 3,000 kilometers south of its current location, or 3,000 approximately, where Baja California is now. This hypothesis is not favored in most plate tectonic reconstructions since it introduces rapid. Since it's too fast, we don't like fast things, slow and steady. Uniformitarianism, no catastrophism, no inkling of it. Don't even play, son. Uniformitarianism, since it introduces rapid, so immediately it's becomes implausible because of interpretation. So, like, I mean, I'm not disagreeing that there is a northern, like, where it formed is where it is kind of aspect to it, but that there, I'm agreeing though for sure there is going to be evidence that there is a Baja California connection. That's it. Since it introduces rapid and plausible displacements of Rangelia across this ocean. Okay. Is why the people doubt it. Okay. Rocks of Rangelia, the individual terrain, not the composite terrain, were originally, so like parts, were originally created in the Pennsylvanian, which interestingly is probably named that way because of its relationship to this current, maybe, that like specifically is around Pennsylvania, maybe. I'm not sure if it has a direct relationship to exactly Pennsylvania. Yeah. Probably just because there's just widespread activity in that period. So around this time, 300 to 300 million years radiometric dating, around that time, the current coming from over here is especially influencing this region. Maybe it's not like just getting there, because I don't think so, but and that it because it's reaching other places, although maybe, but it's essentially beginning to produce lasting observable effects that then lead to us tying a period of Earth's history to Pennsylvania specifically, because the current's cutting across there, so that it has that aspect to it as well. Like, it doesn't have to have those types of connections, it just doesn't have to, but that it does. and then like continues. So even that it says somewhere, like we're not sure where, like we're seeing evidence of Pennsylvanian, but also like probably for an extended period of time before the earth expands while Australia is just sitting there deflecting the currents, or its undersurfaces really, where all the currents beneath it are deflecting the currents essentially, probably. And just their cores in general. Probably near the equator, so there's another reason to support the southern hypothesis, is that it suggests an equator aspect when this current appears to be having traveled along the equator. Appears to have traveled along the equator. Off the west coast of Laurentia. Sorry. Probably near the equator in the Pantalasic Ocean off the west coast of Laurentia, North American Craton. These rocks as island arcs, so they're forming as island arcs, is pretty much eddies that were just more conglomerated, and then just as oceanic plateaus, so it's like larger regions that are up, just enough material there to uplift, but not enough to be above what would end up being the like end result oceanic sea level. And rock assemblages of the associated tectonic settings. It is composed of many rock types of various composition, age, and tectonic affinity, which is to me suggestive of this, like, again, this vortex like thing going on here under, especially under Australia, that's just breaking things apart, like it did to the Indonesian archipelago and all the Southeast Asia islands, etc. All these islands are like from broken up cores, nuclei, pieces of continental shelf that are now like nuclei of new islands. But then because of that, it then paints this picture of this vast array, wherever that was, of composition, of various composition, age, and tectonic affinity. Whatever that means exactly, I'm not quite sure. Late Triassic flood basalts are the defining unit. So essentially, it's all these. It's appears to be like cores, nuclei that maybe are related to this current coming out here and then producing flows that way and this way, and maybe producing eddies this way as well. So it's kind of not just like going straight, but also has some rotation in it to produce like particles large enough in the flow to produce some sort of like cores to mountains as the current comes up here, and then the other current interacts with those eddies to really like ignite the mountain building process, but in a way where it has actually like geological parts, basalts, and then the basalts like trapped because the basalt was sufficient in some way to like form it, just enough current maybe, whereas because this was a deflecting current going along the coast, maybe it wasn't enough current to produce like accrete an entire continental shelf region, but it could produce islands to a degree. Maybe even did produce islands like this. making it basically like basalt as a matrix for just conglomerates. I don't know the exact terminology. Pardon me, geologist. Love you guys. I'm almost 2 hours. Okay, okay. And then interestingly, these basalts extruded onto land over 5 million years, about 230 million years ago, on top of an extinct Pennsylvanian and Permian island arc, constitute a large igneous province. So they extruded onto land, collided and amalgamated with another terrain by Pennsylvanian time. This is this hypothesis at this point. It would be nice to see the basis. What else did I write? Metamorphism in the region. So there's hot. It's a hot current. Intrusions of huge amounts of granite in the coastal ranges, which again kind of ties to these eddies producing just probably like a differentiation crystallization process that makes more granite. It's like a nucleus kind of thing, maybe. I'm not sure exactly why granite. By the end of the Cretaceous, something called the Chugach terrain, which was composed of light materials that couldn't sink. Almost like when two currents are flowing together, they would have like a thing of the lightest stuff on top. That just makes sense in general. I noticed also coral atolls. I'm not sure what to make of that. It would probably help if I knew what that meant. Yeah, okay. So pretty much bubbles. Polygonal bubbles that have coral. Mind you, these are currents, and maybe it is. I mean, maybe it is. But I'm not sure if it takes that. It might just be that the currents created it. Like, it looks like life, but the currents created the coral aspect of it. Although now they might actually be alive in a coral way, because like it's almost like it stabilizes in a new equilibrium, where even though it's just currents colliding, it brings like life out of it. Okay, here we go. In the Cenozoic, basically from when the rapid expansion of the Earth began, in the 56 to 34 million years radiometric dating, the Eocene brought change in the motion of the Pacific plate. So, like, I've been kind of, that's all I wrote because I'm just reading from Wikipedia. That's just to get a bearing on what type of information there is to just go from. So now I need to look into that more. I don't know exactly what to make of it. But I've been generally talking about how the direction of the current changed when the Earth expanded in a way that caused it to go into North America more than down the coastline. So maybe actually like the core here was actually maybe even huge, like pretty much like the whole Laurentia region was just like underlaid by material that just couldn't be, the currents weren't flowing directly enough at to really mess with until the earth started to expand, and then it was able to get into that region too and kind of make it a little less dense, because otherwise like it would be really imbalanced if like only this region of the entire surface of the earth had like the entire region with like just underlying like stableness, like all this. It would just be too stable. Too much like too many neutrons in an atom. Like it had to radioactively decay to have more protons, which these probably behave as in some way. I've talked about that in depth. I'm not sure about how to interpret it in places like this, but in general, they behave like that. Like maybe even like this, where like the more protons there are, the more the channel opens up. But then like it becomes unstable because the next ones gets bigger and bigger. Maybe, I don't know. Or maybe it can also go the other way where they start to get smaller and that's stable. But that's, I don't know. I don't want to be talking about something that's clearly just spitballing. And people will judge me for things that they don't think are worthy of spitballing. Oh, Lord. Okay, so with those things in mind, the shallogram here, the deep caves tied to it, for sure tied to it, the fact that it really reiterates that there was a shallogram here. My thought is maybe we can, real quick, there's definitely a current this way that has been established pretty well. This current looks like it's coming maybe, where is it coming from? Over here? Or here? Maybe it is doing that. It went up this way. It went this way, this down here. And then it looks like it managed to go back this way. Up here? I'm not sure. But now that I'm noticing that, it looks plausible because this appears from here if we keep going. Where was that? I guess maybe not. Where the hell was that? Where was that connected? Pardon me. Where the hell was that? This... Because the reason I'm really curious is because I'm realizing that currents are converging like here, which are leading to this ballooning out, not just here, but more over here. That really maybe did like the whole entire surface like that in some way. Like it's just outgassing, creating space from this collision of currents. One generally coming from the mantle puncture hole this way, which really probably has a boundary here. Here's a boundary, and maybe over here's a boundary. This way, yeah. Here to I guess here. Probably here. ish. Collides with this current over, like, right. This is the collision wall where it built up material there. On this side of it, which means this one's probably a stronger current. Otherwise, it would be more pushing into the boundary. But this current held its boundary, whereas this current coming this way began to form masses in its boundary, which then seems to have funneled, like, because that current almost looks like it got shut off to a degree. Funneled more over here, which probably plays into why, because this current that cuts across here continues all the way over, and runs to the Mariana Trench. So the fact that it's kind of up creating this mound here due to the currents colliding and just the general mound probably caused just a greater current here. Maybe not fully stopping the current across the whole thing, because it really does reach up here too, like the top of the current reaches too. We can even see it right through here, just like in Western Canada, Alaska region, where there's those indentations. So, what would that do? If there's a current coming this way, a current coming this way, then it's kind of squeezing back this way, like a single thread. Maybe we almost need like X currents, but I don't know if they, like, these are just whatever overwhelms each other. This is actually a good example. Here we go. This one's coming this way, and this one's coming this way. And then back here, we notice there's a back current with eddies. A big old current this way, big old current this way, back current with eddies. Of which interact with this current as well. There's a current coming there, making the back current with eddies have this one. Which I guess is why this feature stops here. It doesn't really have like the shallogram features over here. It's really tied to like a back current that was this way, that then ran into the current coming down this way, protruded it a bit. And here, And maybe like this segment that made this one didn't was later than like as it died down, as the currents died down. Like it beforehand was more over here. It's almost like a railroad track again. Is it possible that the Earth, when the current came around this thing and then across, that it then wrapped around here, until the Earth expanded and then it started to wrap more this way? Around this way? Just a straight across, dividing right there. Especially there, so the current's not coming through this side really. Wraps around here. This way and bends here and makes the Himalayas. Guys, it's weird. No one knows what's going on here. I hope on some level somewhere like this is well established that this is happening. You guys are just talking about it, trying to figure out what to do. I wish you guys would just let me know that. But maybe you're like, well, we can't stop this train. No one wants to stop the train. He's doing it without us. Why would we stop him? Why would we give him what he wants? He'd probably fucking start sipping sodas. Got a latte. Fucking sunglasses. One of those mirror shade things covered in lotion floating on some body of water with just a sea of young ladies that are all just throwing themselves at me. I mean, that's... How am I gonna ever get work done? How could... No. Pardon me for assuming anything. That's just the world we live in. Who? How much power? Can I be with him? Lord. Did you think about that? Okay. And it narrows here. It's almost like Greenland was moved. Like it was wider. And the current was, or maybe the current initially was over here, like this way. This way. And then down through here. To have this entire width initially. So like this top segment of Greenland was not like this initially. It was more actually an undercurrent like here, but it got uplifted in the process of the Earth's expansion. Maybe because there's a current coming across here generally. that when this current ran into this current, they kind of deflected away to a degree, maybe, and produced a mound here, which as this mound built, maybe it began to focus this flow more and just make it more direct, whereas when it was wider, it was more just following the contours of whatever it was directing it exactly. So initially with a wider path, it was able to bend more, but then as the channel narrowed, it got more directed exactly across here, which then went this way. Totally turned its direction, maybe even went from a positive to negative energy in some way. The direction of the current, even. That would be crazy. Something that made it just essentially go over here and bend off. Pretty sure the Himalayas started forming in the west and ended in the east, so it wouldn't be that the currents reversed. I was just considering it in my head, but I'm pretty sure it wouldn't be that because they formed from the west to east. So it would be that a current went this way. So maybe just when the earth expanded, that became, it just doesn't look straight on here. So I'm not sure why it would do that unless it was before it expanded. It did that. Maybe once it expanded, it played into Tarim Basin more here. That looks more like it actually, like when it was expanding, the curvature maybe, so it was straight, was over to this region, and then the Himalayas were formed. But then the Earth expanded more rapidly, maybe, like exactly around the Himalayas time frame. In some way where essentially the direction of this current just shifted over and then just stopped here because it stopped expanding. And then like that played a role in the final shaping of this here because there's still some form of cross current going in this general flow path that interacted with that current and just produced the final little smaller ones here maybe that are in this position, because it's kind of staggered. Like why is the positive negative not, why is one not, it's just staggered in a weird way. Okay, I've just said enough in this video. It's already 2 hours 18 minutes. So I'll be back for another one sooner or later, probably tonight, maybe not. Maybe not tonight, it's kind of 11:30 almost. I shouldn't. We'll see. If something happens exciting, for sure tonight, but if not, then probably not. Alright then. Makes sense. See ya.